Hi folks, welcome back. One of the more interesting parts of the recent Gemini 3 launch, to me at least, was this notion of generative UI that they announced. And the idea is to have, as they say over here, a rich custom user experience specific to each prompt. Now, we've seen the beginnings of something like this in things like Canvas or Artifacts, which some of the other providers have. But this seems to go much deeper and is much more integrated into the overall Google experience. So for example, they're rolling it out in the Gemini app itself. And they have even published a paper about how they built this generative UI functionality. And that's what I wanted to take a look at today. This website, by the way, has lots of great examples of actual UIs generated by Gemini 3 with this new capability, and they have all these categories like education or practical tasks or simple queries even. Here's one of the examples that goes into fractals. And so you can see how this is a much more engaging, much richer experience compared to the simple wall of text answer that LLMs usually give. Oh, nice. There's an interactive Mandelbrot over here. Anyway, so let's look at the paper because they explained their system in an accompanying paper. So the goal is to, instead of presenting the user simply with content like text or code, to give them an entire immersive, bespoke user interface as the reply to their prompt. This is their overall system architecture. What they're giving to the LLM, which is Gemini 3 in this case, is access to a bunch of tools, as you'd expect, tools like web search or generating images, and the user's prompt, of course, but also extremely detailed system instructions on how to generally go about making good user experiences. And we'll take a look at these instructions in a bit. The other part they have is what they call post processors. And this is interesting. I didn't expect this. Post processors clean up some of the HTML and CSS and JavaScript that is generated by the LLM. They do small cleanups after the generation. And this entire bundle of HTML styling JavaScript gets rendered in the user's browser. The way they evaluated the setup was to set up a four-way match where they picked a bunch of top queries from LM Arena. And for each of those queries, they presented human raters with four options, or they generated four outputs for each of those queries. And then human raters looked at them pairwise. One was a website created by a human expert. So this is a manually generated user interface. The next one is the generative UI made by this system. Then one was just the kind of current output you see from an LLM, which is just markdown in text, and then just the top search result website. And as you can see over here in pairwise comparisons, the human expert website comes out on top, but the generative UI is a very close second. And if over here you look at the pairwise comparisons, apart from the human generated website, the generative UI is preferred by a very wide margin compared to the textual outputs. All right, so the most interesting part of the paper really is the system instructions. How did they prompt the model to come up with good UIs? And it is a very long prompt, as they say over here, 3,000 words, and divided into 5 sections: the core philosophy, a few examples, planning instructions, technical details, and finally user-specific dynamic information like the date and the user's location, if they choose to share it. So this is how it starts. You're an expert, meticulous, creative front-end developer. All right, so it sets up the persona. And this core philosophy is important. It tells the model to always prefer building interactive web apps, even for simple queries like what is the time or what is the weather. No walls of text. You must verify facts with search. So I won't read the whole thing, but you can see how detailed this is. And then there are a few short examples put in here. User asks, what is the time? Don't just output text time. Do generate a functional, visually appealing clock application. So it's really priming the model to generate UIs for every query. After the few short examples, we come to the system prompt spelling out the thought process itself. So you're not leaving the generation up to the model's chain of thought or the model's reasoning. You're telling the model what reasoning steps to follow. So here it says the first step is to interpret the query, then plan the application concept, not the application itself, then the content, then the data, the images that need to be in the application, then perform searches to gather all this content, then brainstorm what the features are. And finally, after doing all that, you come to the part where you generate the HTML and styling and actually render the query. But you're really telling the model to follow all these steps of thinking and research before coming to generating the UI. Then there are a few guidelines about design sensibility. You must have sophisticated and modern design, how to generate JavaScript. And then the last section is some dynamic information like the date and the location. So you can see what a detailed prompt this is. I think we'll see a lot of exciting developments here because this vision of generating bespoke UIs for every query rather than just a wall of text is really compelling. And this looks like a very promising start. The biggest limitation right now is, as they say, the slow generation speed. It can often take a minute or two. So this is not at the point where you can do this in real time for a big majority of queries. You'd really need to get the latency down in order to do that. But playing around with some of the example UIs they have over here, they look really neat. And so this points to a very interesting future for very custom, bespoke, on-the-fly user interfaces. All right, I hope you enjoyed that. If you like content like this, consider subscribing, like the video, and I will see you next time. Thank you.